In this session, let us understand how libraries function and how the C language uses them. The steps to program in C, or the steps in a typical C development lifecycle, are: step number 1, to write the source code; step number 2, to compile the source code to object code; step number 3, link the object code with a library to create a program executable. If steps 2 and 3 are successful, we get the desired output. Otherwise, we rewrite the code, fix the bugs, and repeat the steps 2 and 3. Although steps 2 and 3 are combined by many modern C compilers, they are in fact separate and discrete ones. In step 3, the linker adds a C library to the object code. So the linker is equal to the object code plus your C library. The C library has object code for functions that perform certain tasks. The C program written by you becomes an executable that runs on the underlying platform once the compilation and linking are successful. This underlying platform may be your laptop, an embedded device, etc. The C standard library is the default library that we saw in the previous session. It contains the implementations for the functions like printf, malloc, and many more. A C program's functionality can be further extended with functions from libraries apart from the standard default library. For example, say to process and work with videos and images, we can use an appropriate C library, say a graphics library. A library file is an archive file. Its file name ends with .a as the file extension. These libraries are static. A dynamic library ends with .dylib. A file name of a library typically begins with lib followed by the library name. The name of the standard C library is Lib2. When a library is linked, only its name is used, and thus the lib part of the file name is excluded. Now the default library is typically stored in the location /user/lib in a Unix based system, which is our standard C library. In a Mac operating system, it's essentially a part of libsystem.b.dylib. Other libraries go in /user/local/lib. Now the linker searches for these locations /user/lib and /user/local/lib for the libraries, both default and other libraries. Now we can have our libraries stored in some other locations apart from these default locations, which can be specified during the compilation time using specific options. Now if we have an IDE, say for example Microsoft Visual Studio or say Xcode, the library's location is local within the IDE's installation folder. Let us now see the location of the standard library in Mac operating system by directly visiting the location and also by using a command line utility called as otool. So here in my terminal, I am currently inside my home directory. So let us visit user lib Within user lib, as you can see, there are so many library files. To find our standard C library, which is a part of our libsystem.b.lib, so let us do a ls libsystem.b.dylib. So this is our standard library, which includes our standard default library as well. Now we can also make use of a tool called as otool to see the location of the library. So in this folder we have a output file for our programs represented by a.out. So let us make use of a tool called as otool to find out where the location of our standard library is in this system. So we can issue the command otool and specify an option -L in capitals, and then specify our executable. So as you can see here, our default library is libsystem.b.dylib within user/lib. So the linker mixes the object code of standard and other libraries with the program's object code so that your program gets additional functionalities. Thank you.